Hey guys, Junkie to Monkey here. So this is the lesson where we're going to really go over the course, what we're going to be talking about, what the structure is, what order we're going to be talking about things in. And the idea is to basically give you guys a good understanding of where we're currently at and what the expectations are, and then how we're going to get to the end game, right? How are we going to get you guys to full understanding? And so what I'm going to do is I'm going to go ahead and flip over to the course outline that I posted on most of our social media, and I'll show it on the screen here too. Also, I'll go ahead and post a link down below to the course outline so that everybody has that when we're going to be doing things as time goes along here. The other thing I would like to mention is a frequency or a schedule of videos that will be coming out. So the idea, I think, or at least the expectation for right now, should be that we're going to try to do at least a video a week. Sometimes we may do more, sometimes we may do less. So let's go ahead and get started here. We'll go ahead and swap over to the course outline, and then we'll kind of go over what we've got going on. So this is the course outline that I was talking about, and essentially I've tried to lay it out in a way that will make sense and that will be easy for people to use. All of these things here are links going to the respective sections. The overview is kind of just an overview of the course. Long term, we will be trying to do more than just programming coursework, so I wanted to create a format that we could get used to using. So this will just basically describe the video series, what our aim is, and where it's coming from. Preparing this section is going to be an outline for like the different things that you'll need to complete the course in general for this series and also in the future series that we may choose to do. I'm not going to assume any previous knowledge, and the expectation will be that anything that you need to know to learn the content that we're talking about will make sure to give you a high enough level of understanding of those topics that you'll be able to follow along with what we're doing in this particular course. There are some pretty good tidbits in here for things that you'll need. Programming environments require you to have certain sets of software in order to be able to do the objectives. We have an objectives. So this will describe like what is the reason for the course, what can you expect to get out of it, and what is our expectation for what we'll be providing to you guys. And with this programming course is really to give you guys a very firm understanding from the ground up of fundamentals and teach you how to program not just in a specific language, right? Not just for a set of functionality that you're trying to provide, which is the frame of mind that a lot of these videos take, is to try to teach you something specific. What we're going to try to do is really focus on the concepts, things that you can take and apply to any number of languages or environments, things that will always remain the same in software no matter how different the technologies are that you're using to do it. Some of the basic ideas that we'll talk about is circuitry and the machinery underneath the software that you're building, binary systems and why they're used, elementary operations, intermediate systems such as memory management systems, operating systems, application layer programs, data structures, design patterns, networks, architectures, and how we interact with them. Things, just all kinds of really good topics, and we'll show you implementations in code as well. But it's really, to be a really good engineer, it's very important that you understand these underlying systems. And if you do, you're already more equipped than a lot of the engineers in the industry. So that's kind of our expectation and objectives for the course. It's not only to teach you to be good programmers, but also give you enough information that you can be good engineers. All right. So then we get into the actual segments of the course. What are the things what is the meat of what we'll be talking about? And throughout kind of defining this stuff and trying to organize how I wanted to lay out this information, something that I really came to the conclusion of was that we should really start in a fundamental understanding of computer systems, electronic systems, and how they work, right? A lot of us aren't coming from an electrical engineering background. or a mathematics background. And so we're going to need to set some base level understanding of things before we can move into some of these other things. So we'll start with the very basics. How do circuits work, right? Well, like, what is it that makes up the systems that we're ultimately building software on? And this will kind of lead into, based on the discussion of circuits and transistors and resistors and switches and all of that stuff, will start to give you an idea for why we might have chosen to use binary in computer systems, right? And we'll get into that once we get on the topic of circuitry and electronic systems. But each one of these things will kind of lead into the next one. Binary is a discussion. I know that's kind of a magic trick that everybody always like. Do you understand binary? Well, I can promise you that it's actually not as complicated as it seems or what you may think. And by the end of that topic, that video, you will understand binary and be able to do conversions or, quote, speak in binary very effectively. All right. The third option, moving on from binary, now we have a basis for what the hardware is and how those systems are doing things under the covers. That led us into binary, why we chose that as ones and zeros, and why that represents our data on our computer systems. The next step to understanding applications is to understand the operations that we have access to. Every language has a set of constructs. Those constructs you're probably familiar with just in hearing about things in passing would be things like if-thens or while loops or variable assignment, things like that. And these elementary operations are often referenced at the architecture level from the CPU perspective on the types of things that CPU will understand. It's important that you understand these elementary operations because that will kind of give you a feel for what the computer languages are doing that you're using and how they might go about performing the things that you're telling them to perform. Computer systems are pretty dumb. They do exactly what you tell them to do. And so understanding what the language and the constructs are doing in reference to the underlying hardware will help you understand and troubleshoot issues that you're coming across. Then we'll talk about intermediate and operative systems. This is things like memory managers, lower level parts of the operating system, and things like that. It's important to understand these things because under the covers, again, your computer programs, your languages, your frameworks, all of those things are using these subsystems, right? These operative systems to perform some set of functionality. And these lower level things are less governed, right? They're less managed. So understanding these systems and how your languages could be interacting with them will make you better at troubleshooting things, especially if you're using a language like C and C++, that very low level language that allows a lot of power, but also can sometimes lead to some detective work to figure out what is actually causing issues. After we get into that, that's where we're really going to move from okay, we've got all of the introduction information there. You have a baseline for what computer systems are, how we are going to interact with the underlying pieces. Now we start getting into, okay, how do we build applications? And this is where a lot of your programming concepts are going to come from. We'll talk initially about, just at a high level, application layer programs and what they're doing. Then we'll move from that into a section I'm calling intuitive objectivity, which is really trying to understand programmers' desire to turn machine language, something that a computer understands, into something that is much more intuitive from the human perspective. So humans understand things generally by patterns. And so by creating an object orientation of these elementary operations, we can start to make the process or the undertaking of creating functionality in an application much more intuitive. So that's what we'll talk about there. The next step is functional programming and design, which is actually quite a bit different, a little bit more abstract than an object orientation style of programming, but it's something that's become very, very, very popular in recent days. And it's pretty clear that ultimately performance, scalability, and accessibility from other industries is going to require this type of programming. The next thing that we'll do is just common language constructs. All of the base level things that every language has and how they're used. So we'll talk here about things like variables, we'll talk about arrays and what the value of those are. We'll talk about things like bitwise operations, referencing back to the binary talk that we had earlier in the lesson. All of the common language constructs, ternary operations, if-then statements, will explain all of those things in detail at a very conceptual level, and then start to look at how these things can be used to accomplish the goals that we have for any applications that we're creating. And then we'll go into implementations of these things. Why are these language constructs used? How are they used? And where can we go with them? Under this section is going to be quite a lot of things. So we'll start to talk about a lot higher level concepts and implementations of those things, but we'll also just be implementing some very basic applications to show some of the different things that at a very base level applications do. The next section will be around performance and scalability. In order for us to understand how good our application is, induction of variables, quantities of data, and so on and so forth, you need a way of understanding the complexity of your application from a timing perspective. How fast is it? And also from a space perspective. So we'll get into the ways that you can look at your applications in terms of something called Big O notation. The next step is data structures, which is one of the most powerful things that you will ever learn in programming. Understanding how they're implemented, why they're implemented, what functions are available on them will allow you to really start to build very good applications. And when bugs come up, and they always will, it'll make it easier for you to troubleshoot those things and create very clean, good applications. We'll talk about things like linked lists, hash maps, and we'll even go into some sorting algorithms. The next step is going to be design patterns. Now, this is a very intuitive lesson because it's a way for us to look at applications and fit them together. The best ways to take disparate frameworks or libraries and use them in a way that will create highly efficient and scalable applications. The next set of lessons will talk about the whole wide world. The internet allows us to access information on basically any topic. We'll talk about networking systems, how the browser is implemented, what it's really doing in order to really create that conceptual understanding. And then lastly, we'll talk about architecture and software. How do we build modern systems? What differentiates applications that, say, Google creates from an application that some mom and pop shop down the street creates? It is actually pretty simple once you understand what they're doing, what they're trying to accomplish. So those are all of the things at a high level that we'll talk about. Each one of these things may have individual videos underneath them. We are going to try to keep the videos small. This video will probably be one of the longer ones, as we're kind of just going through and describing everything. One more thing I did want to talk about. These videos do take quite a bit of time to create. So because of that, I decided that if we're really going to learn, it's definitely better to do it together. So what I decided to do was create 3 different plans. If you want some interaction, I'm going to go ahead and provide that. So the first plan is $10 a month. I'm calling it the community plan. This will give you access to a private Discord, which will allow you to chat with other patrons about the different topics and applications that they've built, the homework that was done regarding the course, a number of different channels to discuss different types of improvement opportunities, or just, means to show off this new application that you've built. It'll also give you access to me on a little more direct of a scale. The second plan is the student plan, so you'll not only gain access to the Discord, but There'll also be a private Google Drive for the course. You'll also have access to all of the homework exercises and the ability to submit them to me. You'll have tips and tricks I'm going to put in there, different like hints and things like that to help you guys along the way from video to video, as well as the ability to submit your work to me, which will return to you feedback and questions on why you chose to do something so that you really can get better over time. The next package, which is the highest one, you'll receive all of the previous levels, as well as a private GitHub repository with many different solutions that I'm going to put out there that will allow you or give you the opportunity to work with other people. So one of the most valuable things in technology is experience. A degree is one thing, and it definitely is valuable, but experience is king in this industry. And so your ability to say that you've worked with other people on projects, on a team, in a source control mechanism will give you a huge advantage over people who are just fresh out of college or don't have any experience. So I decided to do these things mainly to help you guys more, but because it does take so much time to do this stuff, I am going to put these things up here. I'll also put a link in the description of the video with the Patreon link so that you can do that as well. Alright, so that's pretty much it for this video. I kind of just wanted to talk over the course and what we'd be doing here. And thanks again for watching, guys. Make sure to like and subscribe below so that you can be notified when new videos are posted. We'll see you next time.